Hello class, welcome to another lecture. Today we're going to be talking about section 7.2, which is about the addition and subtraction identities. So first what we're going to do is we are going to create them. So let's see how to do that. That's always more fun than using them. So let's discover some identities, which remember, it's just relationships between the trig functions. So what we're going to do is we are going to investigate this picture here. And a bunch of cool stuff is going to happen. So we are going to pretend that there's a line that goes across here, and it has length 1 on this rectangle. And so this is a rectangle, so these are all 90 degrees. And then we're going to have another line that goes across here to form a perfect right triangle. That's the setup to figuring out some neat new formulas. And then we're going to name the angles. So that's going to be called alpha, and this angle here is going to be called beta. And then we're going to fill out a bunch of these missing sides, and it's going to reveal some formulas. That's going to be the idea. Okay, so let's start doing that. So the first thing we're going to do is we're just going to think about this inner triangle here, which I'll outline in red. So let's think about that triangle. And let's think about if we could see how long each side is. So what do we know? We know things like, if I call this y and I call that x, then I can say that sine of the angle is opposite over hypotenuse. And so I can say that y is just sine of that angle. So that missing side here, whoops, erased too much. That missing side here is actually just sine of beta. And then similarly, cosine of that angle is what? It's x over hypotenuse, aka adjacent over hypotenuse, so it's just x. So this side here, this missing side here, is actually just the cosine of that angle. So that's 2 of the sides. So now we're going to keep going from here. So let's see, what else can I investigate? I have to think about it. How about if we look at this triangle, this green triangle here. So let's think about that triangle. So now I know that this length is cosine of beta. So what is this thing going to be, and what's this thing going to be? What are these missing sides going to be? Well, I can use the same idea as before, which is I know that sine of the angle facing it, which is alpha, is opposite over hypotenuse. So if I just multiply that cosine up, I now figure out the that side. So it's cosine beta sine alpha, but people usually write it as the sine first, so we're going to do it like that too, just for later. So now we figured out another side. So this is going to be sine alpha cosine beta. That's how long this side is right there. Okay, and then we can still figure out the other side, this x, by using cosine. So cosine of alpha is going to be adjacent over hypotenuse. And so what am I going to get there? Multiply the cosine up, and you get cosine alpha times cosine beta equals x. So now I know that this side is cosine alpha times cosine beta. So right now we're just sort of filling out information, but after we're done, we'll see what it tells us, which is more cool stuff we can do. Okay, but let's keep going. So what about this? Let's do this blue triangle. It's going to work just the same. So how do I do that? Well, I'll draw it down here. So what do I know about it? All I know right now is that this side length is sine of beta. And I don't know anything else. I don't know any of the angles, but I can use some sneaky tricks to figure out these angles here. So for example, if this angle here is alpha, then because triangles have to add up to 180 total degrees, and this is already 90 here, and then plus alpha more, then this angle here is the rest. So it's actually 90 minus alpha. That's what that angle is there. But then what we can say is that, okay, if that's 90 minus alpha, a flat line is 180 degrees. And so I've already got 90 minus alpha taken up. I got another 90 there. So I need 180 total. So what I have to do is think about 90 plus 90 minus alpha. That's two of the angles. That's this angle and this angle. Plus something has to add up to 180. So what's that something? Well, 90 and 90 already makes 180 minus alpha plus what? How do I get rid of that alpha? It has to be a plus an alpha there. So this angle here is actually alpha. So that's the trick to this one, is that I can actually figure out that that angle is alpha. And then I could do the same trick I just did, that I did for this green triangle. So I can think about y and x, and I can do the same stuff. So sine of alpha is opposite over hypotenuse. Tells me that y is sine of alpha times sine of beta. So that's what goes all the way up here. That's this little piece here. So sine of alpha times sine of beta. And get rid of that dot actually, because I haven't been using the dot notation. So it's just sine alpha times sine beta. Oh, I guess I did use it there. Okay, I'll put dots in. Sine alpha times sine beta. All right, so that's how you get y here. So what about x? Same idea, just use cosine. Cosine alpha equals, opposite is, or sorry, adjacent now because it's cosine over hypotenuse. And then you multiply across again, and you get this, sine beta cosine alpha. So that is what goes here on this question mark. So I said sine alpha, sorry, I said sine beta cosine alpha is what goes there. And then let's see, what else are we missing? The last triangle here, I've run out of colors. Let's see what else we got here. Should have something. I guess I'll use this. Okay. So this last triangle here, we can fill out too. So what do we know about it right now? All we know is that this length here is 1, but we're going to figure out the angles the same way as before. So everything will work just the same. It's a bit more interesting though. So first of all, this angle here is 90 minus alpha for the same reason that the other pink one was 90 minus alpha. But then this angle here, because that middle triangle has to add up to 180 degrees, and you already got beta and you already got 90, the leftover piece has to be 90 minus beta. So then this angle here is what? How do I figure that out? Well, it needs to add up to 180 for the flat line, because the flat line has to be 180 degrees. So this 90 minus alpha plus 90 minus beta plus something needs to add up to 180. Well, what would that something have to be then? Well, I already got 180 minus alpha minus beta plus some mystery amount equals 180. Well, I already got 180. So I got to cancel that alpha and that beta, so it's got to be alpha plus beta. So that's the trick to finding this angle here. It's actually alpha plus beta. Okay, so now we have that. So then what can I do next? So I can say the same thing I have been saying. So y and x here, and then I can do that y is sine, sorry, let me do it the way I've been doing it. I can say that sine of that angle is opposite over hypotenuse, so it's y over 1. So actually it's just sine of alpha plus beta, and that's what y is. And so that tells me that this left side here is sine of alpha plus beta. So it's sort of weird because you're adding the angles together. And then the same technique tells us that cosine of alpha plus beta is the x side over the hypotenuse. So then I can also fill out that top part. And that's cosine of alpha plus beta. So this is the complete picture. All the sides are filled out, but what does it tell us? So let's zoom out here. What does all this work tell us? So let's see, I want more colors here. Okay, this will be fine, I guess. Pink. So rectangles are nice because their opposite sides are the same length. So for example, this side length here is this amount plus this other amount. So that's that total side length. So if I take that piece and I add this other piece, sine alpha times sine beta, that should equal the opposite side, because it's a rectangle, so the opposite sides are the same length. So if I add those two things together, I should end up with cosine alpha times cosine beta. And then what people do is they solve for this piece to create a new relationship. That is, you get cosine of alpha plus beta is cosine of alpha times cosine of beta minus sine alpha times sine beta. And this is called an addition formula or a sum formula, or an addition identity or sum identity. Because you're figuring out how to take cosine of the sum of two angles is the idea. So these are two angles added together, and this tells you how to break it apart and figure out cosine of that angle. Okay, So this only works if we know the smaller angles. The alpha and the beta angles. Okay, so that's if you look at the opposite sides, the vertical sides. If you look at across here, sine alpha plus beta has to then also equal this, whoops, that went too far. Has to equal this side length plus this side length. So you get the other formula. So then sine of alpha plus beta is the left side of this rectangle, has to add up to cosine, let's see, cosine alpha sine beta plus sine alpha cosine beta. So that's what those two sides were over here, except I wrote them differently, so let me write them the same. So this is the way that people write the formula typically. They put the sine alpha first. So they put this piece first. And then on the second piece, they put the sine first also. Or do they? I guess it doesn't matter, but I'll just do it how my notes are because that's what people probably do. So we'll do it. We'll follow that. Okay, but it's the same thing. All right, so these are the two sum formulas, and we're going to use them to do things. But for now, just enjoy. This is what they are, and they tell us how to compute sine of or cosine of the sum of two angles. And you can also change them into difference formulas by just introducing a negative and doing the whole thing I did over again. So these are the difference formulas or the subtraction formulas or the subtraction identities or difference identities, however you want to say it. And all you do is you change the plus to a minus, and that'll change the signs in the formula there. So that'll change that minus to a plus. And then other than that, it'll be the same formula. So you'll get cosine alpha, cosine beta, plus sine alpha, sine beta. And then for sine, if you change it to a minus there, then, oops, then let me write it how I have it here. This guy will change to a minus. Okay, so these are the four formulas that you got to know, or you can always look them up again if you forget them, so you don't really have to memorize them, especially with an online format. And you can just use notes on tests and things. But these are the four formulas we'll be using to do some examples now. That was just how to get the formulas, which I think is worth sharing so you can see where things come from. Otherwise, if you don't see where they come from, then I don't know, it sort of loses its purpose and meaning. Okay, so now let's see how to use them. So we can do problems like this now. Find sine of pi over 12. So pi over 12 is not one of those good angles where you can just look and say, oh, it's this. So we can't do it the old way. And instead, we have to use this new formula. So it's just a trick. It's all just a trick. Everything in this class is just tricks. So the trick is you take your angle and you break it apart. You break into, it's up to you, a sum or a difference. Doesn't matter which one. So what I mean is take pi over 12 and think about it in pieces. So what's a couple ways to think about it? I can think about it as, how about 6 pi over 12 Sorry, no, let's not do that. Let's do, I can think about it as if I had 4 pi's over 12 and I took away 3 pi's over 12. And so what I'm doing is I'm breaking it into smaller angles, not just randomly, but in a very smart way where these angles I understand better. And maybe you don't see that right away, but once you reduce, that's when you see that. So 4 over 12 is 3, and 3 over 12 is 4. And I know about pi over 3, and I know about pi over 4, and that's the key to doing this problem. Because then you can just look at thinking of pi over 12 as pi over 3 minus pi over 4. And then you can use a formula at this point. So it's okay if you don't remember it right now, but because we just learned it, but this is what it is. So the difference formula is you take sine of the first angle. So this is like your alpha, and this is like your beta. So it's alpha minus beta. So you take sine of the first angle, you take cosine of the second angle, you subtract, because this is subtraction, and then you do cosine of the first angle. Oh, sorry, I wrote pi over 3 here, but that should have been a 4 because you do the other angle. So then you subtract and you do cosine of the first angle times sine of the second angle. And then the whole point is that sorry, podcast just played for no reason. Okay, so the point is that I understand all of these smaller pieces. I know what sine of pi over 3 is, or I'm supposed to remember that, so we know these pieces. Okay, so what is sine of pi over 3? Let's see, I have to think about that. Root 3 over 2. Cosine of pi over 4 is root 2 over 2 minus, okay, cosine of pi over 3, that's a half, and sine of pi over 4 is root 2 over 2. And then you simplify a little bit. So root 3 times root 2 is root 6, and then you multiply the 2's to get 4, and then you stick the denominators together, or not, the denominators are common, so you can just add them up like that, and there you go. Okay, so the main trick to all of these problems is just figuring out that first step of how to break up this angle that you start with. It's always the same other than that. So let's do another one. Find cosine of 5 pi over 12. First step is think about 5 pi over 12, and you have to break it up in a smart way. So here's not a smart way, and you can tell me why. Pi over 12 plus 4 pi over 12. Why is that not helpful? It's because the two pieces are not really easier than the initial thing. Pi over 12 is not any easier to work with. So you really haven't progressed at all if you just use this way to break up 5. So you have to think a little bit harder. What else could I do? I could do 2 pi over 12 plus 3 pi over 12, and that would work. Or I could do, let's see, I could do 8 pi over 12 minus 3 pi over 12 would work. There's lots of ones that work. It's up to you to decide. Let's just use this one for now. Okay, so then cosine of 5 pi over 12 is what I'm looking at. I've broken up the angle into two pieces that are a little more bite-sized and understandable, because when they reduce, I get two angles that I understand better. And then I can just use my new trig formula. So my new trig formula tells me, and again, you won't know this immediately because we haven't used it enough, but I have it to look at. So cosine of the sum of two angles is cosine of the first times cosine of the second minus sine of the first times sine of the second. Okay, and then we can just compute these pretty quickly. So cosine of pi over 6, that's root 3 over 2. Cosine of pi over 4 is root 2 over 2. This one, sine of pi over 6 is a half. Oh, this is going to be the exact same answer as last time, but that's okay, that can happen. Okay, you get that again. Doesn't always have to be that. Just happened this time. Let's see, what else can we do? So I think what I'll let you do is I'll let you try these, and I'll just give you the start. Start is the hard part. So to do something like this, or this, it's really the same problem. All you have to do is figure out how to rewrite this guy. And then you just plug it into the formula. It's all just a formula. So what's a good way to do this? How about 9 plus 3? Or wait, 9 plus 2, sorry. That's one way. And there's other ways too. Or 8 pi over 12 plus 3 pi over 12, for example, will also be good. And this is how you do all of these problems. Okay, so then the only slightly harder type of problem is something like this. Solve cosine of, so it's a trig equation, so it's solving for x like last time. It looks initially much more complicated than the stuff we did before. But if you just realize it looks just like a formula we've been looking at, then it's not so bad. Okay, so it looks tough, but you need to recognize that this is one of those formulas. Because it's really cosine of some angle times cosine of another angle minus sine of that angle, sorry, that first angle, alpha, times sine of that second angle. It's really of this form, where what are my two angles? Alpha is 5x and beta is 3x. That's all it is. So if I just go and look and match the formula, I'll see that this is actually cosine. This is the cosine formula. This is cosine. So before I didn't know what it was, so there's the question marks. But all it is cosine of the sum of the two angles. It's that formula. So that big thing, what it really turns into is just cosine of 5x plus 3x. And so what we get is that that entire left side just turns into this, and it makes the equation much simpler than before. So we get that. And now it's just like last time. So how did we solve this last time? You say, when is cosine root 3 over 2? So maybe you draw a little picture to help you figure out those x value, or those angles that get you that x value, and it's pi over 6. And so that's what you set the inside to be, plus a full rotation amount. Or it could also be 11 pi over 6. And then you divide by 8. Okay, so this is the other type of problem, but they're all pretty similar after that. So I'll just finish writing the solution up. But that's it. Okay, so if you want more practice, what you can do is you could change these to other multiples of pi over 12. And that's pretty much it, actually. Okay, so no daily problem. I will see you next time. That's it for today.